Okay, we are going to go over some of the problems on the 5-5 Solve by Factoring worksheet. Now, I'm calling it an in-class worksheet because normally if I do something like this in class, I'll go over a few of the problems with you and then have you finish the assignment and turn it in as an assignment. And so that's exactly what we're going to do. I'm going to go over some of these so you have a chance to see how they're done, and then you have a chance to repeat that on the other problems that I don't go over. And then you will submit it as a worksheet or as an assignment. Okay, so let's go ahead and start. Number one is find all roots by using factoring. So that's what we're going to be doing the whole time. But number one, when we look at a problem like this, we see a common factor. Okay, so we see x is a common factor. We're going to take that x out. We get x squared plus 4x minus 5. And so those are x is a factor, x squared plus 4x minus 5 is a factor. Now I'm going to factor this quadratic. If it factors, which it does, plus 5 and x minus 1. Double check by foiling it back together to see if it works, and it does work. So x is equal to 0 for this factor, negative 5 for this factor, and positive 1 for this factor. And so that's how you do those, and that's basically what we're going to be doing. However, not all of them are going to be the same exact factoring methods. All right, the other three in this, the next three are just like this. So you should be able to do those. Let's go to number 5. Number 5 is a factoring by grouping method. You notice there's 4 terms. There's also a cubic. Now, I should have mentioned up here that a cubic has a potential of having 3 real solutions, but also it might have 3 complex solutions, which not also, but it will have for sure 3 complex solutions. Well, it happens to be all 3 of those complex solutions are real. So anytime you see a problem like on number 5, it's also a cubic. So therefore, it has 3 complex solutions, which we don't know if they're all real. Maybe they're imaginary, maybe they're irrational, which are still real. But so we're going to keep that in mind as we go through them. Okay, so we're going to factor by grouping. So I'm going to go ahead and group the first 2 terms and also group the second 2 terms. I'm going to take out a greatest common factor out of the first group, which is x plus 3. I'm going to take a 2 out of the second group, leaves me with an x plus 3. Now when you factor by grouping, these 2 have to be the same. And they are, because now I know this is x squared plus 2 times x plus 3. Now, one of my zeros is negative 3. I know that right there, because x plus 3 is a factor, so negative 3 is a 0. If I set this one equal to 0 and solve, I subtract 2. I get x equals plus or minus I square root of 2, because I'm going to take the square root of both sides, which is the square root of x squared and the square root of negative 2, gives me plus or minus I squared of 2. So that is my second 2 zeros, or my last 2 zeros. And here are my solutions. Okay, the rest of these are done exactly like this, so you should be able to do those next 3 on your own. Okay, the next set of problems, 4 problems, are just like this, same one. I'm going to do number 9, and you should be able to do the rest from there. Okay, so what we're going to do here, this one is called a quadratic form, which means it has the same form as a quadratic equation, where the first degree is twice the middle degree. And when that happens, just like a quadratic, where you have x squared plus 3x plus 2, that's an example of a quadratic where the first degree is twice as much as the last, or the middle degree. Well, that's the same thing here. So what I'm going to do here, instead of putting x and x, I'm going to put x squared and x squared instead, because when I multiply those, they get x to the 4th. 2 factors of 4, 4 and 1, give me the 5x squared in the middle, and 4 as the last term. If you FOIL this back together, you'll see what I mean. Now, I'm going to set each one of these equal to 0. And solve. I'm going to subtract 4. I get x squared equals negative 4. X is equal plus or minus the square root of negative 4, which again is plus or minus 2i. If I subtract 1, I get x squared equals negative 1, so x is equal to plus or minus I. So these are my 4 zeros. I have a 4th degree polynomial, should have 4 complex zeros. Some of them will be real and some of them will be imaginary. You will never have an odd number of imaginary zeros. Okay, so you should be able to do these other 3 just like that. Now, the last one I'm going to do is number 13. If you notice, it has a greatest common factor, which is x cubed plus 125 left. Now, this is a sum of 2 cubes, which we just got done learning how to factor. So you should be able to factor this. We have x plus 5 for my first factor, and x squared minus 5x plus 25 for my second factor. Now, anytime that you factor a sum or difference of 2 cubes, the quadratic factor will not be factorable. So we cannot factor that any further. Anytime you take the sum and difference of 2 cubes and factor it, you're going to have to use the quadratic formula to find the zeros of the quadratic factor. So at this point, I know 2 of my zeros is 0 and negative 5. My other 2 zeros have to be in here. So I use the quadratic formula, 5 plus or minus the square root of 25 minus 4 times 1 times 25 all over 2. So x is equal to 5 plus or minus the square root of negative 75 over 2, which if I simplify that is 5 plus or minus 5i square root of 3 over 2. So there are my 4 solutions, 0, negative 5, and then the 2 solutions that are imaginary. Okay, so that is how you do the last 4 problems. Good luck. Let me know if you need any help, and I can show you the steps of another one if need be.